The formation of the solar system. Our solar system is 4.567 billion years old. Have you ever wondered how the Earth, the planets, and the solar system formed? The solar system is a collection of billions of asteroids, meteors, planets, and other strange things too. For now, let's focus on the Sun, which is a G2 star that gives us light and heat and stands in the center of our solar system. 4.6 billion years ago, there was once a huge cloud floating in space. But then, something happened. It is not known for sure what happened, but it could have been a supernova explosion disturbing it, or a huge cloud ramming it. Either way, this allowed the huge cloud to receive many more elements and minerals, and this caused the cloud to implode and allow the remaining dust to stick together and form a protostar. This protostar is our Sun, and the explosion formed a protoplanetary system, known as our solar system. The Sun is an extremely huge object that lies in the center of our solar system. It is a G2 star, which is not as big as stars can go. Our Sun is more of a medium-sized star. The Sun is so colossal that about 1 million Earths can fit inside of it. It is also one of the most special celestial objects in the solar system and holds 99.86% of the mass of the whole solar system. The remaining 0.14% is the rest of the solar system. First, the star has an extremely hot inner core with a temperature of 15 million Kelvin. The inner core is stupendously dense due to gravity. The inner core remains as plasma, which is a state of matter exceeding the gaseous state due to the terrifying heat. Electrons cannot form into atoms in plasma, so it is filled with whizzing nuclei and electrons. Next is the radiative zone, where photons are radiated in random directions for hundreds of thousands of years, until they find their way towards the surface. The next thing up is the convective zone, where when all the photons reach the convective zone, they start to cool, allowing them to fall back into the radiative zone, repeating the process. You might be shocked, but the Sun actually has an atmosphere called a chromosphere. This is the lower atmosphere, and it is also 6,000 Kelvin. Finally, we have the corona, which is surprisingly 1 million Kelvin. Scientists are not sure why, but they think it might be because of the magnetic field or acoustic energy. On the surface of the Sun, there are dark areas called sunspots, which are cooler areas. This is where the lines of the magnetic fields loop. Also generated by the magnetic field is the prominence, which is the crest of the plasma. The Sun can also cause solar flares, which are explosions of burning plasma. Solar wind is also caused by the Sun, which is a constant ocean of plasma that reach mind-blowing distances. The limit is the end of the heliosphere, which is also the end of the solar system. The solar system consists of 8 planets: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. The first 4 planets are known as rocky or terrestrial planets, while the last 4 planets are known as the gas giants. Between Mars and Jupiter lies an asteroid belt, which is a belt full of rocks and dust. The remaining material was spewed out at different distances from the Sun from the axis of rotation. These formed planetesimals, which were the remaining dust particles of the implosion that stuck together. These are smaller baby planets. These planetesimals collided with other planetesimals over the next 1,000 years, forming larger objects or planets. These baby planets formed the rocky or terrestrial planets we know today. Meanwhile, the same process happened to the outer planets, also known as the gas giants, but also a lot of ice crammed in too. The planets have a spherical shape because of gravity pushing the dust and gas in, allowing all of it to stick together. The lighter objects moved away from the Sun, while the heavier objects moved closer. There was once a theory where Jupiter was once further away from the Sun, but then moved closer. What about the asteroid belt? Some of the planetesimals formed asteroids, and because of the strong gravity pressure from the gas giants, these asteroids moved closer to form a belt that is now the asteroid belt. When the solar system formed, all the planets lined up in a fashion so that you could imagine the solar system in a disc-like shape. Have you ever wondered why all the planets are lined up instead of planets roaming around in different directions? Well, if you didn't know, the Sun spins too, and because it spins very fast, the stuff coming out of it allows the planets to line up. Mercury's elliptical orbit is 7 degrees, Venus's is 3 degrees 24 minutes, Earth's is 0 degrees, Mars's is 1 degree 51 minutes, Jupiter's is 1 degree 18 minutes, Saturn's is 2 degrees 29 minutes, Uranus's is 0 degrees 46 minutes, and Neptune's is 1 degrees 46 minutes. Pluto's elliptical orbit is 17 degrees 9 minutes, which is very different compared to the other planets. This is one of the reasons in 2006 Pluto couldn't be considered as a planet because of its irregular orbit. Since then, it has been classified as a dwarf planet. Each planet rotates around the Sun in an axis, which is the amount the planet is tilted. Mercury is tilted 0.1 degrees, Venus 177 degrees, Earth is tilted 23 degrees, Mars 25 degrees, Jupiter 3 degrees, Saturn is tilted 27 degrees, Uranus 98 degrees, and Neptune 30 degrees. As you can see, Venus happens to have the largest tilt in orbit and Uranus comes second. Mercury happens to have the smallest tilt in axis, with 0.1 degrees. Now, you might be wondering the solar system consists of the 8 or 9 planets if you include Pluto. Well, you're wrong. The solar system has much more than just these 8 planets. Just after Neptune's orbit starts the region of the Kuiper Belt, crowded with thousands of objects consisted of rock and ice. The Kuiper Belt is named after the Dutch astronomer Gerard Kuiper, who was the first to propose its existence. The Kuiper Belt stretches from 4.5 to 7.5 billion kilometers from the Sun. You might be wondering how all these objects got here in the first place. All the gas giants have extremely strong gravity pulls. If one of these Kuiper Belt objects get too close to their gravity pulls, the object will get flung into a random orbit. However, most objects in this region have more stable orbits. The first Kuiper Belt object to be discovered was Pluto, discovered by Clyde Tombaugh, an American astronomer. Yes, that's right. Pluto is a Kuiper Belt object. Pluto's orbit overlaps Neptune's orbit. But wait, why doesn't it get thrown into interstellar space due to Neptune's gravity pulls? When Pluto is at perihelion, which is when the planet is closest to the Sun, it orbits well above Neptune's plane, so both planets won't physically collide. It actually took another 6 decades to find another Kuiper Belt object. Right now, more than 1,000 Kuiper Belt objects are known. In 1978, Pluto was found to have a moon named Charon. A few years later, 4 more moons were found: Hydra, Nix, Styx, and Kerberos. The next region is the scattered disk. The scattered disk overlaps the Kuiper Belt from the 3 inner edge and stretches to 150 billion kilometers away from the Sun. This is also 25 times further than Neptune. In this region, orbits are all strange and tilted due to the objects being pushed into random orbits by the gas giants. The scattered disk is also where short-period comets come from. These are comets that orbit the Sun in a short period of time, roughly around 200 years. Finally, we have the Oort cloud, which is a spherical cloud of dust that contain about 1 trillion of these objects. It stretches from 300 billion to 10 trillion kilometers out. The Oort cloud was named after Jan Oort, who first proposed it. The Oort cloud is the origin of long-period comets, which take more than 200 years to orbit. Thank you for watching.